so I know this is a little bit early, but I figure some of you might want to knock this out of the way. So you'll notice that the review sheet here has a lot of scatter plots, only because we just are finishing our two-way tables, so it's still fresh in your mind as opposed to scatter plots we did last week. So that's why I added a little bit more of that. Okay, but I mean, I know it seems like it's a lot, but it's only because when you put it on the paper, like the first page only has 4 questions. You know what I mean? They're big. I couldn't really make it any smaller. Anyways, enough of me talking. First one. Here's an equation, right? So the line of best fit, they did a line of best fit, so it was an equation, and apparently the line looks like this. Okay, so it's a negative y-intercept, so somewhere around here, negative 20.51, and it looks like this. Okay, so that's the line. Y equals 0.32x minus 20.51, and it represents the number of times at bat, and y is the number of hits that you get. Okay, so how many hits would you expect from a player who is at bat 175 times? So again, the x represents the times at bat, and this y represents the number of hits. So if you wanted to find out how many hits you're going to get, right, you're going to multiply it by 0.32 and then subtract 25 ones. So in this case, there's a baseball player. He's going to be, I don't know, for during the season, he's going to go at bat 175 times, not during the season, but for, let's say, a quarter of the season. He's going to go to bat 175 times, and how many hits will he have? All right, so that's easy. Y equals the total number of hits is going to be 0.32, and he's going to go at bat 175 times. So we're going to put it over here, replace the x, 175, minus 20.51. So then it becomes just a calculated problem, right? 0.32 times 1.75 minus 20.51. So predicted 35.49, and let's just call that 35 times. So when he goes at bat 175 times, he'll get 35 hits. That's the prediction. That's it. 2, let me see, just scroll down a little bit to see what kind of question. So we want the correlation. Yeah, just the correlation. Is it a positive, strong negative? Is there no correlation at all? So, so if you ever been to Washington, D.C., around March, April, there's a section there where there's a lot of cherry blossom trees that Japan had donated to Washington, and they blossom, and it becomes really popular during that time, early spring. So they want to see if there's a correlation between the date in which they bloom and the temperature. So the date in which they bloom depends on the temperature. So temperature I'm going to put over here. It's going to be my x-axis. And the date is going to be my y-axis. Blooming date, I'm going to call it. That's going to be my y-axis. So temperature here, I don't want to, see, I can do 1, 2, 3, 4, 5, and then 6, right? I don't need any more than that. But because it's so tight, maybe I can spread it out. 1, 2, 3, 4, 5, and 6. I can. So much easier, right? Because then the points are not all like bunched up together, right? And then up and down, we're going to go, what do we need? We need up to 28. So maybe we can do 5. Every 2 is 5, 10, 15, 20. Yeah, we can. 25 and then 30. Good, perfect. So let's start with the first one. We said when the temperature is 1.5, the blooming time is 28. So 1.5 is right here. So we're going to go about here. 28, 20, 25, 27.5, 20, right here. When it's 5.8, when the temperature is 5.8, around there, the blooming date's on the 3rd. You'll notice that it blooms earlier, so the 3rd will be about right here. When it's 2.4 degrees. 2.4 is around here. The blooming date is on the 25th, so around this point right here. When it's 4 degrees, the blooming date is the 21st of April. You should really go see it if you ever have a chance. When it's 4.7 temperature-wise, the blooming date's on the 14th, which is about here. When the temperature is 5.4 degrees Celsius, blooming date's on the 8th. Which, speaking of, we're not too far from it right now. When the temperature is 3.2, the blooming date is on the 20th. I wonder if there's any truth to this. And then when the temperature is 5 degrees, the blooming date's on the 6th of the month, right about here. So I'm going to say that there is, right? And that's the line, my line of best fit. But there is a negative correlation here. Pretty strong one, right? Right, let me just, I guess, maybe I should move this guy here, just like that. So I'd say that it's a negative, strong, negative correlation. Right? The higher the temperature, the sooner in the month the cherry blossoms bloom. Okay. All right. So again, all that you knew how to do already. This one, multiple choice. Oh my God. So I'm going to. So for these ones, you might want to construct something like this and just think about the context of the story. So we're talking about the age and the height of the elementary school teacher, elementary school students. So here are the ages, elementary school, right? Make this a little longer. And you don't have to be, I mean, again, it's just for you to have an idea of what happens as they go older. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-year-olds. I'll stop there. And then their height, right, in inches, whatever it is. So we definitely know that as they get older, and this is the height, right, I don't have any points, but as they go older, right, what happens to their height? They get taller. So you can say that there is a positive correlation because the height increases and the age increases. So if both values increase, that means there is a positive correlation. So the answer to this one would be C. Clear grid? No, clear objects, clear notations. Next one. The graph below shows the relationship, okay, between the distance in miles the delivery truck traveled and the number of hours each delivery truck took. So the longer he drives, right, the longer it takes to get there. So they imagine you created a scatter plot, you drew a line of best fit, and now you're going to find the slope, right, and eventually the equation of the line. What is your next step? Well, the next step is to pick 2 points. Okay, you're not going to pick these points over here. So anything that I circle in purple is not the points that you're supposed to pick to do y2 minus y1 x2 over x1. You don't want to select these points, right? The points. So after you draw your line of best fit, you look at the line and you look for 2 points that are on the line. And in this case, they have one for us, and those 2 points are the points that I would use because I can actually tell you what they are. This one over here, for example, is 610, right? And this one over here, we can actually find out that it's 300 and comma between 8 and 6, 7. So those are the 2 points I would use to find the slope. Do we have any multiple choice to have that? Yeah, we have it right. 610 and 300, right here. Look. So the key here, and please try to remember because you're going to have a question like this where you're going to plot the points and then draw a line of best fit, and you have to pick 2 points to find the equation of the line. So you want to pick 2 points that are on the line, okay? And if it happens to be one of the 2 points that that were given to you, and that you plotted, great. If not, then you pick 2 points that are on the line. So the answer to that one is D. And that's page 1. See, told you. Page 2. Which graph shows the weight of dogs and the time it took the same dogs to complete an agility course? So think about agility course, right? I'm pretty sure you've seen it on TV. The ones that they run up and down and they go, there's those stakes and they have to go in and out, in and out, in and out, and all that stuff. So it's saying the weight of the dogs and the agility, right? And the time that it takes for them to complete those kind of courses. So can we safely assume that the heavier the dog is, or the heavier the dog is, the more time it's going to take? So they're comparing. So our two variables here are weight, right, and second. So most of these graphs, except for D, says that as your weight increases, guess what happens to the time? It goes up. But, in this case, sorry, I'm rambling here. The only thing that they're looking for, they plotted all the points for you, and they're asking for the line of best fit. Well, obviously, let's start with this one. This is definitely not the line of best fit. This is also no, because the line of best fit is above all the points. It shouldn't be above all the points. It should be somewhere going through the middle. This one, also it's not, because, sorry, this one the points are below, and this one all the points are above. And this one, I hope you can see it, that the line goes through the middle, and you have some points above it and some points below. So that would be the line of best fit. So C is your answer. D, 8, which represents a positive correlation. Again, remember what a positive correlation is? Both one value increases and the other one increases as well. So both values have to go up. So in letter A, your Y value is decreasing and your X value is increasing. So that's not positive, that's gone. This one, it's a U-shaped, not even positive, so automatically gone. And now we're left with C and 8. B, there's no correlation here. So just by knowing what a positive correlation looks like, right, you have the Y values increasing and you have the X values increasing. And look, if you draw a line of best fit through it, it's a positive slope. So the answer is C. Using the last line of best fit, predict the average consumption of bottled waters in the year 2000. So you can find this, pick 2 points, find the equation, do the slope, and then substitute 2000 and everything. Or we can use, so they plotted the data given, they drew a line of best fit, and we're going to use the line of best fit to answer our question. So in the year 2000, we're going to use the line of best fit. In the year 2000, according to the line of best fit, this right here, and I'm going towards it, would be, what is this? 12, 14, 16, this is 20, so between 20 and 18, 19 gallons. And that's our answer. Okay? Yeah, so much easier when they're all multiple choice. This one, sorry. So, graph the data on the scatter plot, draw a line best fit, and do all that stuff. Okay, so we have 2007, 2008, 2009, 2010, 2011, 2012. So what we're going to do here, our data starts in 2010. So 0 would represent our year 2007. 1 year after would be 2008. And we're going to go all the way to 12. So 1 year after, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5. Okay, so 2008, 2 years will be 2009, this will be 2010, this will be 2011, this will be 2012, and this will be 2013. I just want to show you what those numbers represent. So on my x-axis, it represents the years, and my y-axis is going to be the sales. So a little trick we can do here, and I'll let you know on the test if I'll create a graph. We can use a little break here because I don't want to go from 0, let's say 0, 10, 20, 30, and get all the way to 300. Or notice that we don't need the numbers, any numbers from 0 to about 300. All those are not even part of our data. So I'm going to do a little break here that says I'm going to take a break, and I'm going to start with 300. So let me do this a little better. So if on the test you have a question like this, I'll make this for you so that you know. That's 300. And we need up to 420. So we're going to go 320, 340, 360, 380, 400. So let's do by 20. 320, 340, 360, 380, 400. And I'm going to do one more line here, and then it's going to be 420, right? So that's 410, and this is 420. Okay. In 2007, our first year, we have 305,000 in sales, so that's about here, 3,000, right here. In 2008, which is 1 year after, it was 330, which is about here. 2 years after, 345, which is about here. 3 years after, which is 2010, is 370, 360, 370 right here. 4 years after, which is 2010, is 395, which is about here. 5 years after, is 420, which is right about here. So now you're asked to draw a line of best fit, right? So you got a line right up. That looks about right. Okay. Just make it. Yeah, that's about right. And then we're going to pick 2 points, and again, pick 2 points on the line. All right, so my 2 points on the line, I'm going to pick this, my y-intercept, first of all. So that point is going to be 0, 300. And then my next point, one point here that we can see, I'm going to pick, does that go exactly, well, I won't make it exactly here. No, here, this point here, it's on the line, and I can tell what that is. It's 1.5 and 340. So those are the 2 points that I'm going to use to find my equation of the line. Okay, so the slope is going to be, I'll do the slope, 340 minus 300, 1.5 minus 0, and we get 40 over 1.5. Let's divide that up. And that's going to give us 26 point, and now I'm going to round up 26.67. Okay, rounded. So my equation looks like this so far. Y equals 26.67 x plus b. And to find my y-intercept, actually, I don't even need to do calculations for b because I already know what b is. B is right here, right? 0 and 300. So my y-intercept is 305, sorry, 0 and 305. So that's part 1. Part 2 says, according to your equation, in what year will the sales reach about 500,000? Okay, so if we were to continue our line best fit, so it'd be somewhere over here, right? And it would be this point, like this, and we would have to find the year. But because we don't have that, we're going to use our equation. So in this case, 500 is not x, because x represents the number of years, and this is going to be y. 500 is going to be our y, so 500 equals 26.67x plus 305. We're going to subtract 305 from both sides. We're going to get 195 equals 26.67x. We're going to divide both sides by 26.67. Let's divide that. 195 divided by 26.67, and that's going to give us 7.3 years. So x is going to be, so the number of years, in how many years will it reach 500,000? It's going to be 7.3 years after the year 2007. So 2007 plus 7.3 years is going to be 2014, and then 0.3, right, around March. So, but actually, They want just a year, so we can just say 2014. So that's my final answer. Okay. Here, oh, you're definitely going to see a question like this. Again, here is scatter plot. Find the line of best fit. So let's use what we know. The slope is positive, so right off the bat, well, actually all of them is positive. So they're all possible right now. The y-intercept. So let's look at the y-intercept is this guy right here. So that looks like about a 50, 56, 57. So it's definitely not this one because this one has a y-intercept of 60. So we know it's not 60. Definitely not this one because it says y-intercept of negative 84. So it's either this guy here or this guy here. We just got to figure out. So unfortunately, we're going to have to do the slope. So they picked 2 points from us, for us. And let's just find the slope really quick. So 90 minus 65 over 25 minus 7. And we get 25 on top, right? And then 18 at the bottom. And if you simplify that, 25 divided by 18, you get 1.388888, which obviously they round it to the nearest tenth and they get 1.4. So A is our choice. Okay. This one, which relation is shown by the scatter plot? Well, we definitely know it's a what do you call negative relation. So we have to look at the multiple choice here. As the cost goes down, the number sold as the cost goes as the cost of the gym goes up, what happens to the memberships? It goes down because you have less people buying, right? So that's what's happening here. You know that as the cost of the gym membership increases, the number of new memberships goes down. So as the cost goes down, the number sold goes down. That's not it. As the cost goes up, the number sold goes down. That's our answer. Let's see C. As the cost goes down, the number sold remains the same. That's not it. There's no relation. Well, that's definitely not it. So B is our choice. Okay. 14. Pick 2 points of less and determine. Pick 2 points of best fit. Pick 2 points. Notice that I'm stressing these types of questions. Hint. So you plotted the points, you draw a line of best fit, and now you're supposed to pick 2 points. We're not going to pick these guys here. Let me change colors. These guys are not on the line, so don't pick these ones, right? The ones in green. Do not pick the ones. So you want to pick from the 4 that are left. Look, they're on the line. Pick the best one. And the best one, and I'll put it in red, would be this guy here, because I can tell what the value is right here. This one's a nice point. That point is 1500 is 12.5, right? Because it's between 10 and 15. And this point here looks pretty. And that's point 2000. And that goes with 10. Okay. So I'm going to call this x2, y2, x1, y1. It doesn't matter, remember. So we're going to do 1500 minus 2000 over 12.5 minus 10. So it's going to be negative 500, right? So we know it's going to be a negative slope over 2.5. So let's divide that. 500 divided by 2.5 gives us exactly 200. So negative 200 is our slope. So y equals negative 200x plus b. Pick a point. Well, let's pick this nice point over here. Let's plug it in. 2000 equals negative 200 times 10 plus b. 2000 equals wait, did I do something wrong? 500 divided by 2.5. That's 12.5 minus this minus this. 12 minus 10. So this gives me negative 2,000 plus b. So we're going to add 2,000 to both sides. And our b is 4,000. Why is this kind of weird? Sorry. Did I do something wrong? X1 is 2010. And then this one is 1500 and 12.5. Something is off. Sorry. Let me just double check everything. This point here is 2010. This point here is 1512.5. So let's subtract. Oh, I did it backwards. Ugh, sorry. Forget all that. Forget all that. So m equals 12.5 minus 10. Sorry. Over, right? 1500 minus 2000. Yikes. So it's 2.5, negative 2.5 on the top. Sorry. 2.5 on the top and negative 500 at the bottom. And then our slope is going to be 2.5 divided by 500. Our slope is going to be 0.005 negative. So y equals negative 0.005. X, and then plus our y-intercept. Guess what? We have it. Y-intercept is right here. And that's between 20 and 25, which is 22.5. So that's our final answer. Sorry, I made a mess of this question. But that's our slope, by the way. Which represents the correlation of the situation correctly. So we gotta read this. As the size of the dog increases, as the size of the dog increases, the amount of food that you purchase goes down. Nope. As the cost of the plane ticket goes up, the number of tourists flying to Hawaii goes up. Nope, doesn't make sense. This one, there's no correlation. As the temperature goes up, the number of people swimming should go up, but this one is all over the place, so this one is not up. Let's see if the last one makes sense. The number of customers at a store goes up, and the sales goes up. That makes sense. So our only choice is D. 16, the true or false. So they did the scatter plot again. Read it. It says the number of consumer negative reviews. As the number of negative reviews goes up, what happens to the number of cell phones that are sold? Well, it goes down, right? Because nobody wants to buy them. So the points, 37 is about here, and 890, which is about 890 should be about here. And well, that point right here, I mean, it's about here, and the point 98, which is about here, and 505 are on the line of best fit. No, that's false. Are those 2 points on the line? They're not on the line. The scatter plot represents a negative correlation. True. It's reasonable to predict that if there's 75, so let's look at 75 right here. There's 75 negative reviews. The number of cell phones sold is going to be close to 600,000. Let's check. So if there's 75 negative reviews, it's hitting right here. And if you look at your y-axis, it matches with 600. So this is true. So the only one that was false was A. Again, thank God. What do you call it? They plotted the points for us. We're going to draw a line of best fit. That's the line. So this is not the line of best fit. This is not the line of best fit. It goes through the middle of the points. There's some values above the line, some values below. So, sort of half and half. That looks okay. Oops. So we're going to move that line right about here. And we want to use the line best fit. So now we have to pick 2 points on the line. The best 2 points on this line. Yikes. I'm going to approximate. Okay, so let's pick this point. Actually, this is a nice point. That point there is, what the heck, 250. Wait, which one is 250? That's, I think this is 250. No, that's 250. 1 second, please. 200. Is that 250? Is that 500? I think that's 750. That's 1,000 over here. And this is 1250. I hope I'm reading that right. Give me 1 second. So let me see what this point right here would be. This is about something above 250. Distance in miles, that's 374. Is that if that's 250, no. That's 125, and that's 125. I don't know what 250 is. 1 second. The point 600. This is 143, and 143 is about here. Let me just move this for a second. So they have this point 600. 600 is about here, right? About here, and they have it with 143. 143 is not there. 143 is about here. Why do they have? Pick another point. 374, which is about 125. 375. So it's about here, and it's with cost of the plane ticket 125. I think that's wrong. I think this is 250. This is 500. This is 750. That's 1,000, and this is 1250. Let's see if I'm right. So it was 143. No, it was 600, 500, 750. Around here, 600 is 143. Yeah, that's correct. All right, so now I know the values. Okay, sorry. So let me put the line best fit again. So I'm going to pick 2 points. Well, let's pick this one right here. Put it in red. So that looks like 250 and 100. And then I'm going to pick another one. Oh, God. Pick one. Approximate. I'm going to use this point right here. It's on the line. So remember, you have to pick a number on the line. So that's 1,000. And the y-axis matches with about, I don't know, let's call that 190. All right. So x1, y1, x2, y2. So we're going to do the slope. So it's 190 minus 100 over 1,000 minus 250. It's going to be 90. Over here we're going to have 750. We're going to leave that as 9 divided by 75, 0.12. So y equals 0.12x plus b. Let's pick a point. I'm going to pick this point right here. So I'm going to substitute. I'm going to get 100 equals 0.12 times 250 plus b. So 0.12 times 250 is 30 plus b, and b equals, we're going to subtract 30 from both sides, b equals about 70. So my final equation, 0.12x plus 70. Okay, and that's sort of, you know, if you were to extend this line, so sort of looks like it's going to hit y-intercept of 70. Okay. Here they're asking us to plot this, and then just simply, not even the line, thank God, they're asking just to find if there's a positive, negative, or no correlation. So temperature is going to go here, because the water that you consume depends on the temperature. So this is my independent, my dependent, and this is going to be my independent. So water consumed, let's say we need up to 50, so 10, 20, and that's why I like to make these lines over here, 20, 30, 40, 50. And up and down the temperature, you know what, I'm going to take a break right here, and we're going to start at, because I don't need anything under 80, right? So let's just make this 80, I'm going to go 85, another 290, another 2 boxes 95, and another 2 boxes 100, just so they're all not bunched up. So when it's 99 degrees, so temperature, oops, I did it backwards. So temperature goes in here. So take a break, and that's going to be 80, 85, 90, 95, and then the next 200. And then over here, I can go by 10s, 10, 20, 30, 40, 50. All right, so when it's 99 degrees, I consume 48 of water, so somewhere around here. When it's 85 degrees, I consume 27 of water, somewhere around here. When it's 97 degrees, I consume 48 of water, right about here. When it's 80 degrees, how much water we consume? 16. When it's 92 degrees, we consume 32, somewhere around here. When it's 88, we consume about 34, somewhere around here. A little bit under that line, actually. When it's 94 degrees, we consume 40, so around here. And 83 degrees, we consume about 20, so somewhere around here. So now you can clearly tell that this is a positive correlation, a strong positive, right? As the temperature goes up, our water consumption goes up. So you can call that a strong positive. Okay. 22. Determine the correlation. So the number of people at your party and the number of sodas you have in the refrigerator. So I guess if there's more people in my party, the more sodas I'm going to put in my refrigerator for them to drink. So they both goes up, right? So that is a positive. That makes sense. The amount you drive to school and the amount you have to pay for gas. Well, the further I drive, the more I drive, the higher the amount you have to pay for gas, and the more I'm going to have to pay for gas because the distance is greater. So that's also positive. The size of the dog and the number of times you have to take it to the vet. That has no correlation. The size of the dog does not dictate how many times you take it to the vet. So no correlation. All right, that's what you would write over there. Finally, two-way tables. Oh, we're done with scatter plots. Clear objects. So this is just about filling, and seriously, I think you guys should have no issues with this one. So we're going to start here. So 75 minus 33, it's going to give us 42 over here. So something, and we're going to go across. Something plus 20 is 42, so that makes that 22. Let's go up and down. 22 plus 15 is 37. Let's go females. Find the number. The total females is 33. There's 15 already, which makes this 18. And up and down makes this 38. So completing the table should be no issue. Again, over here, let's go this way. Let's add all the boys. 85 plus 29 plus 54. That's going to give us 168. We can add these two and then subtract from 366. 366 minus 168 minus 171. It's going to give us here our number 27. We can add these three in school B. 29 plus 31 plus 5, and that's going to give us 65. We can do, well, we can do these two. Well, let's do these here. So it's 191 minus 85 minus 13, and our missing number is 93. And then over here we can do 27 minus 13 minus 5, and our mystery number is 9. And let's add this up and down. 54 plus 47 plus 9, going to give him 110. And then if you want to check, make sure these three numbers add up to 366. And make sure these three numbers also add up to 366. Okay. 80 students out of school, so we can automatically put this over here. We're surveyed whether they have an iPod or not. Half of the 58 grade students, so look in this column, it says half of the 58 graders, so we know there's 50, and half of them said yes, so half of 80 is not half of 50 is 25. And 28 of the 7th graders said yes. 28 of the 7th graders said yes. There. Complete the two-way table. Super easy. 28 and 25 is 53. 53 plus something is 80. That'd be 27. Something plus 50 is 80. That'd be 30. 28 plus 2 is 30. And then 25 plus something is 50 would be 25. Done. Now we're going to look at this table over here and answer the questions to the right. How many chemical engineers chose science? So here are my chemical engineers. You're going to look at the row. Ignore everything. Look at the chemical engineers, and how many of them chose science as their favorite subject? 91. How many engineers chose math? So, right here, right? There's electrical engineer, chemical engineer, mechanical engineer. So the number of people who chose math was 254. Overall, what was the favorite subject of all the engineers? Well, you got to look at the total here. Either math was more popular or science was more popular. In this case, science was more popular. Okay. Overall, which means another word for total. Look at the left and answer the questions on the right. Of the students playing games, these are the students playing games, what percent were boys? Well, there were 138, sorry. First of all, let's start with the total. How many students were playing games? 192. What percent were boys? 138. Divide, multiply by 100. Divide by 192 times 100. So we're going to round it to 71.88%. How many girls prefer watching videos? Here. 188. Sorry. Girls watching videos right here. 142. What's the relative frequency of boys watching videos? The rule of boys watching videos is 46, but remember, 46 out of 380. Of the people who prefer burgers, and these are the people right here, right? So notice what we're missing right off the bat. We need a total column here and total over here. So let's just add this up. 23 and 31 is 54. 42 and 26 is 68. Going around, to the side, 23 and 42 is 65. And then 31 and 26 is 58. Let me add these two quickly. No, did I do something wrong? 30. That's not 58, it's 57. If I add these two, I get 122. If I add 54 plus 68, I also get 122, so I'm good. Of the people who prefer burgers, how many people prefer burgers? 68. How many of them were females? 26. 26 out of the 68 who like burgers were females. We want a percent. Divide, multiply by 100. 38.24 rounded to the nearest hundredth. One of the students is picked at random. Let's complete the table first. So here, 80 minus 38, we get 42. 13 plus 13 is 26. We can do this number here. Something plus 14 plus something plus 13 equals 42. So we can do 42 minus 14 minus 13. And we get 15. Something plus 15 is 33, which is 18. 18 plus 13 is 31, so this would be 7, because 7 plus those numbers is 38, and this is 21. So let me just confirm. That's 80. 21 plus 33 is 54, and that's 80 as well. So we're good. So, what's the probability that of the students picked up? One of the students picked at random. So how many at random? So one of them out of 80. What's the probability that the student that I picked is a female? How many females were there? 38. And probability, remember, you can leave it as a fraction. 38 out of 80. Write down the probability that the student visited the library on Tuesday. How many people visit the library on Tuesday? There were a total of 33. So 33 out of 80 again. Okay. How many people? Oh, we gotta fill in the form, the table. So 30 plus 60 is 90. 45 plus 15 is 60. Add these up, we get 36. This should be 54. And this should be 9. Good? Yep. How many people who had 20 or over driving lessons, right here in this column, failed the test? 36 people failed the test. What fraction of the people failed their driving test? How many people failed their driving test? 60 over 90, or 2/3 of the people failed their test. Yay, 2 more questions. Oh my god, these are completely empty. Okay, 150 people right here. Visit a school cafeteria. Some students pack lunch. Okay. Okay, so this is pack their lunch, and this they eat cooked lunch. And there were males, and there were females. Okay, those are the categories. All right. Some students have a cooked lunch. Well, 56 out of the 89 who have packed lunch. So 56 out of the 89. So that's telling us that there's 89 in total, and 56 of them are females. And then 72 are boys, right? That they don't tell us about whether they pack food or cook food, which means this is the total. So telling us 72 are boys. So that's plugging my information. Let me find the rest here. So now we can add and subtract. 150 minus 72 gives us 78. So that number right here. We can go up and down here in the packed lunch. What is that? 89 minus 56. It's going to give us 33 over here. We can now go across. 72 minus 33. This is going to be 39. We can go across again. It'd be 78 minus 56, which is 22. And we can add this. 61. Let's just add up and down. This adds up to 150. Check. This adds up to 150. Check. We're good. What percentage? So, okay, percentage. I need a fraction first of the students in the cafeteria. In the cafeteria have cooked lunch. So, first of all, how many kids in the cafeteria? 150. And how many of the 150 have cooked lunch? 61. Oops, they want a percent. 61 divided by 150 times 16. 40 point rounded 67% of the students from the cafeteria have cooked lunch. And the last one, again, empty, 100 people. Study a language. Some people start French, Spanish. Did we do this? What's the other language? German. Ugh, that's a tough one. And again, females and males. Females and males. All right. 54 of the people are male. So in my male column, total is 54. 20 out of the 29. So 29 is a total of something. 20 of the 29 who study Spanish. So in my Spanish column, I know there's 29 people, and 20 of them are females. 31 people study German. So in my German column, on the total, I put 31. And then 15 females study French. 15 females, so look over here, and then French would be the first box there. Let's start adding and subtracting. So let's do here, this is going to be 46. Let me change colors actually. This is going to be 46, easy. So now we have 15 plus 20, which is 35, and then 35 plus 11 is 46, so we have that number. Go up and down, we need 31 people speaking German. We already have 11, so we need 20 more. 20 plus 9 is 29, so we did this. We can find males who speak French, so we need a total of 54. So 54 minus 29, this is going to be 25. We can add these two now, we get 40. 40 plus 60 is 100. Yeah, we're good. What's the probability of picking at random a student who studies Spanish and is a male? Where's my Spanish and male? Males and Spanish right here. So what's the probability if there were 100 people? I took all their names, put in a hat, and I pick one that speaks Spanish and is a male. 9 out of 100. I have a 9 out of 100 chance of accomplishing that. And that's it. Please break this up into parts.